All right. So if you're just popping in or if you're watching the recording, the link here on the screen, I'll put it one more time in the chat so that it's on the recording. What you could do there is peruse the different practice tests for PARCC. You can try out the calculator that you'll have access to during PARCC testing. So just some tools to help you feel more comfortable and more familiar when you start that testing next week. Okay? What I'm going to do, and we won't take the time right now to watch this, also because you might not need to watch this. What the link is, I know. Well, the first one, the one I've put in so far, Tristan, is the same one over and over. The one I just put in, that's a new one. So click on, just save it. And of course, it'll be in the recording, but that's the one from the bottom of the page down here. And what that one is a proof of the theorem we're going to talk about today. It is also in your slides. So as you go through the slides, it will go through the proof. But I thought this might, just be an extra thing, a visual, rather than just going through the slides, if you're kind of lost when you go through that proof. Okay? All right. So here's the theorem we're going to start out with, 3.07. And 3.08 is going to build off of this. It's called the side-splitting theorem. Okay? And the objective for 3.07 is to use the side-splitting theorem to solve problems. So we won't go over the, yes, no more links. I know, we just have two, but if you're getting lost with all the links, just send me a K-mail. I'll send you the important info. How's that? Don't get overwhelmed with the links. But yes, we're not going to go over the proof today during Class Connect, but I did send you the link for that. And we're just going to talk about what it says and how to apply it. All right, so here it is, the side-splitting theorem. It says a line parallel to one side of a triangle divides the other two sides proportionally. So what does that mean? Well, let's take a look at the picture first. So you have two triangles. Can you guys tell me the two triangles that you see here? Tell me what the two triangles are. Okay, Will says triangle AEB and CED. Very good. So you have the big triangle on the outside, and then there's one inside of the larger triangle, CED. Okay, good. And I love how Will put the little tilde, the squiggly, because that means similar, and that's what the side-splitting theorem does say, although it doesn't specifically say it, but it is true. So good job, Will. You read into that these two triangles are going to be similar. And that is because the sides are proportional, and then we could also, and when you go through the proof, they will prove to you that the angles are equal. Okay, and remember, we've been talking for the past two Class Connects that those are the two criteria for similar triangles. Okay, so let's take a look at the requirements. So a line parallel to one side of a triangle. So remember, the arrows indicate parallel, right? So we have CD and AB. Those are two sides of the triangles we're looking at here, and they are parallel to each other. So here's what it says. It says, well, okay, if you see those two parallel sides, you can create this proportion. So what it's going to do, basically just think of the smaller triangle, the side that's parallel, kind of chopping the sides. Okay, so we have AC is, you're going to put that over the other sides. Okay, so what I'm saying is look, let me color code, might help to see this. So you're just going to look at the two sides that are not the parallel sides. Okay, so let me put one in blue and one in red. Okay, so here are the two parallel sides, right? We have CD and we have AB. We're going to look at the other two sides. So side AE of the larger triangle and CE of the smaller triangle are going to be proportional. We're going to put those into a fraction. Do you guys see that? So I want to make sure that this page makes sense to you, because we're going to apply it here in a second. So AC is the side of the larger triangle, and CE is the side of the smaller triangle. Okay, same thing's going on over here with the red side. We have BD, which is the extra little piece from the larger triangle, and DE is the smaller triangle. So notice how AC, if you look carefully at AC, we're not doing the whole entire side. It's just like the extra piece that's not part of the smaller triangle. Okay? All right, so let's see if you were paying attention. Here is a question for you. According to the side-splitting theorem, which of the following proportions is true? Now be careful, because there are two answers that are true here, but this says according to the side-splitting theorem. Okay, so I want you to pick the one that is true according to the side-splitting theorem. And I'll take it off of follow for a second. If you happen to find that you did not pay as well of attention on the last slide as you thought you did, you can go back and look. Okay? So give this one a shot. It should not take you too long here. I'll give you about 15 seconds. Ready? Go. Okay, Aspen, Ben, Brooke, Bryce, Delia, Devin, Keely, you guys want to lock in an answer there? Give it a shot. All right, here we go. I'm going to publish the poll. Good. Mostly C's, and that is correct. So very nice job. Okay, let's take a look at A and D. Those were the other two answer choices. So let's see. A was AC over DE. Why do you think A isn't correct? And can anybody help? For those that put A, can you guys help them out? Why would this one not be correct? You can either type it in or jump on the mic.
Well, for A, basically they're comparing two different triangle sides, and both of those sides are on opposite sides of the transversal. Or, well, not transversal, the upper parallel.
Beautiful, beautiful. Give them a round of applause. That's great. And I love that you said transversal, because you are right. That's where this is coming from, is way back to semester 1, unit 3. We are talking about transversals. That's where the proof's going to come from. So that's true, that line EB and EA are going to act as our transversals. But yes, that's a little more detail than we need. But exactly. So when we're talking similar figures, okay, and I know, again, this doesn't specifically say similar. It is true that the triangles are going to be similar. But we've been talking about that the past couple class connects, so the same idea is going to apply. We really are just looking to see which sides match up. AC and DE are not corresponding sides or matching sides in those triangles. Okay, let's take a look at D. That was the other. Nobody chose B. So let's take a look at D. AB over CD. Okay, why is that not correct according to the side-splitting theorem? Because what sides is the side-splitting theorem talking about? Good, Destiny. Yes, so if we go back, let's put back on follow and go back a slide here. It says the triangle, the line that's parallel, divides the other two sides proportionally. Okay, so it's talking about the other two sides in this theorem. So you don't ever want to involve CD and AB if it says according to the side-splitting theorem. Okay, you don't want to use those parallel sides. Okay. Like I said, there might be some truth there, but the question says according to the side-splitting theorem. So we want to apply the ideas from that. Okay? Yes, perfect, Ben. Okay? Okay, so here we go. We're going to use it. Do I have a couple volunteers that think they have the side-splitting theorem down? Anybody want to set this up and give it a shot? So we have triangle TSU. Okay, that's okay, Delia. I know last time you gave it a shot, but not quite there. That's fine. We'll do a couple, and then I bet you'll feel more confident. Awesome, Ben. Let me give you whiteboard privilege. All right, so Ben can do number 6. Anybody want to try number 10? All right, Will. I figured Will might give it a shot as well. Okay, perfect. Now, if you guys, if you're in Delia's spot and you're like, I am not quite sure I want to get on the whiteboard with this yet. I'm not feeling that confident. That's okay. That's why we're here. And I want you to try it on your own. Okay, so while Ben and Will are working these out on the board, see if you can at least see if you can get the proportion set up. And I'll take it off of follow again if you need to go back a couple slides and look at that theorem one more time, okay? So give it a shot. Okay, so I don't know if you guys have all had a chance to do both of these yet, but hopefully at least 6. That was enough time to kind of take a look at it and get it set up. Give me a smiley face if you understand where Will's coming from here. Were you able to get this proportion? Give me a smiley in the chat or a smiley on the screen. Delia, what do you mean by are they the same? Are 6 and 10 the same? Is that what you're saying? They're 2 different problems. The triangles, I mean, it's a similar idea. We're going to use the side-splitting theorem on both of them. You see 13 on both? Let's see, Delia. Let me give you whiteboard privilege. Point to what you're talking about. Oh, I see what you're saying. You got, I see. Yes, well, this one is almost the same, but 13.5 is different than 13. Yes, I see what you're saying now. So they're close to the right answer, but definitely 2 different triangles, 2 different sets of information there. Okay, so let's talk about now what I'm going to do on 6. Let's see, Ben did 6. Perfect job. And I'm going to write it out just because I know it's hard to type. And you guys do an awesome job of trying to write it out with your mouse, but I know writing it out with your mouse is difficult, so you go to the typing, which is fine. I'm going to write it out with my mouse, though, just so you can see what it would look like, you know, because most of you are probably going to write it like this if you write it by hand. Okay? And this is how you would set it up. So again, what you're doing when you set up a proportion using the side-splitting theorem is you're going to take the 6, which comes from the extra little piece of the larger triangle. So again, you're focusing first on your parallel lines. You want to look for that. And then we're going to take the extra little piece that's formed between those 2 parallel lines and put it over the side of the smaller triangle. And that's where the 6 and the 14 are coming from. Delia and Keely, is this making sense to you too? Okay. And then WU, which is the smaller piece or the piece in between the 2 parallel lines, is going to go over the side that's in the smaller triangle of 21. Okay, so as long as you can get to that part, that's the geometry part. Okay, and as I say a lot in this class, a lot of times it's not the geometry that messes you up, it's that you forgot Algebra 1. So what do we do from here? Will showed us here. What did he do in the second step? I mean, Ben. Sorry, Ben did 6. Good. We're going to cross multiply. So we are going to take 6 times 21 and x minus 4 times 14. Now, my caution here to you guys is be really careful when you cross multiply. I want you to write it out like this. When you do 14 times x minus 4, make sure you put parentheses around the 14 and the x minus 4. So if you see addition or subtraction, it's really important that you remember to put the parentheses, because what are we going to do over here on this side? Ben did that for us. How did he get from 14 times parentheses x minus 4? So he did a beautiful job of putting those parentheses in there. How did he get to 14x minus 56? Because I can tell you now, there's going to be a few of you that are going to mess up right here. This is a common place to forget. You're looking good. Type those answers in. And what are you going to multiply by 14, Tristan? So you're right. We're going to multiply by 14. And Will, you said distribution, which is perfect. What does that mean? We're going to take 14 and multiply it by what? The x and the 4, yes. So remember, that's where you have the little rainbow thing going on. You do 14 times x, so that's where Ben got the 14x from, and then you do 14 times negative 4 as well. And so minus 56. Okay? Now on the other side, that's more straightforward, right? Just 6 times 21. And then I think you guys can follow what Ben did from there. Okay? But I just wanted to point that out on number 6. Now on number 10, I love how Will did this. He set it up a little bit differently, correctly. He just didn't write out the entire proportion to begin with. He did a little bit of, he divided 18 by 12 first, and then cross multiplied kind of all in within those first 2 steps. So just to be sure, in case you didn't set it up that way, another way to do this would be 18 over 12 equals x over 9. Give me a smiley face if you set it up like that. Anybody get to number 10 yet? Stephanie did. Destiny did. Good. Ben did. Good. And that's really, Will did do that, but notice what Will did was he divided 18 by 12 first, which is algebraically totally fine. That is an allowed rule. And he said, well, that gives me 1.5. So then I have 1.5 equals x over 9, and then I'm going to multiply by 9 on both sides. Okay? So that's good. I love it when you guys jump on the whiteboard because then we see other variations, other ways to solve this. Okay? So that is an acceptable way rather than, I know on 6, like I said, we cross multiplied right away. But you could also, if you can also divide and then multiply by the denominator. So, well, Tristan, let's not say weird. Let's say unique, because it's totally correct. And I love that Will does it differently, because it's always good to see, that's the good and the bad with math, right? There's always, not always, but a lot of times more than one way to do it. And some of us see it one way and some of us see it another. It is, Tabitha, it is. And so that's why I said I love that Will brings that perspective in to us. Yes. All right, I want everybody to give this, I'm going to turn off the chat. I want everybody to give this one a shot on your own. In about a minute, I will start to write it up on the board just in case you're stuck. But I want you to see if you get it. Now, the tricky part with this one is it's turned upside down. So one thing that might help you if you're really lost on how to set up the proportion, you can redraw the triangle there on your scratch paper and flip this where the end's up at the top, if that would help. Okay? So give it a shot. Everyone should have their scratch paper out and be starting their proportion. All right, so I put a proportion that you can have using the side-splitting theorem. Anybody write that differently? If you did, you want to put it on the board just so I can look it over and see. And if you were stuck, let me know if that helps you out or if you still have questions. Anybody write that out differently? Good. Yes, so that also works, and that was Tristan, right? That is totally another way to write it. I love that. Again, another perspective. So you can definitely, again, you're just making sure, sorry about that, you're making sure that you're matching all the sides up. That's the key there. Yep. All right. So now what are we going to do from here? How would we go about solving this? And Tristan, you want to keep going? You're welcome to. Show us what you did next. Yes, Ben, we're going to cross multiply. Yes, this one's tricky. We do cross multiply, and Stephanie is ahead of us. We are going to have to end up foiling. And that's why I put this one in here. I don't think you're going to have one quite this hard on your quiz, but like I said, what we have on the screen right now, that's the geometry part. So if you forget after this point what to do, don't blame it on me. Blame it on Algebra 1. Okay, very good. So Tristan's going with it. He took 2 times 4.5. That's where the 9's coming from. And beautiful work putting the x plus 5 in parentheses and the x minus 3 in parentheses. There you go. Okay, no problem, Sarah. Thanks for letting me know. There you go, Tabitha. I like that. Yeah, just blame it all on Algebra 1. Perfect. Okay. So FOIL, what does that mean? Anybody remember that? Are you guys kind of like, oh, I kind of vaguely remember that. There you go, Ben. First, outside, inside, last. Nice. Okay. And that occurs anytime you have 2 things being added or subtracted in parentheses, and you have those parentheses being multiplied together. So we're going to do first x squared outer. The x and the 5 are on the outside of each parenthesis. Inner, negative 3 times x. And last. The last terms in each of those parentheses are the negative 3 and the positive 5. So we get a minus 15. Very good. All right. Anybody remember how to go about solving a problem when you have an x squared term and an x term involved? So we have run across problems where we just have an x squared and that's it. But now we have an x squared and then we have a couple terms here that also have an x. How do we have to solve those? Definitely good. Good start, Delia. We want to combine like terms. So we can put the 5x and the 3x together. Uh, 2x, not 3x. Let's see, did I mess up? So we have x squared minus 3x plus 5x minus 15. I'm not seeing it Stephanie, can you tell me, you have whiteboard tools, you could point, show me what you're saying there. Are you just saying if you combine 5x and 3x? Okay, so I combined like terms. Now what do we do? Okay, gotcha, Stephanie. Okay, it looks kind of like crickets here. What you want to do is you want to get everything on one side. Nope, don't add 15 to both sides. What you want to do is you want to get everything over to the same side where the x squared and the x is at. Okay? So we're going to subtract 9 actually. And what we're going to get over here is a 0. So we're going to have x squared plus 2x, and that would give us a minus 24. Okay? So again, you might need a review of algebra rules, but this is true anytime you have an x squared term and an x term. You want to get a 0 on the other side, everything else on the side with the x squared and the x. Okay? Now what we want to do is we're going to have to unfoil. Okay? So remember how the x goes at the beginning of each, and then we find a number that multiplies to negative 24 and adds to positive 2. Okay? So can you think of any numbers that would multiply to, negative 24, not a positive 24. So we want it multiplying to a negative 24 and adding to a positive 2. Good. 6 times negative 4 multiplies to a negative 24. And then 6 plus negative 4 adds to a positive 2. So those are the numbers that I'm going to put in my parentheses. Positive 6 minus 4. And then from here I have 2, because remember from Algebra 1, anytime this part of the parentheses is 0, it would multiply to 0. Anytime this part of the parentheses was 0, it would multiply to 0. Because what is anything times 0? If I had 10 times 0, what would I get? 0. What if I had negative 2 times 0? Okay, and so there's 2 little mini algebra equations we have to solve. If you remember the shortcut, you really are just changing the signs. Okay, so our 2 answers there are negative 6 and 4. Is that my answer? I know you guys love this class because when we find x, we're not always done, right? Yes, we still need to find MP. So let's go back up to the picture. Oh, let's see, Tristan. I'm sorry about that. You should have had the same thing I did. Oh, you know what it was, Tristan, right here. When you had positive 5 times negative 3, you added, you want to actually multiply that. So right here, you would have had a negative 15. Yes, I know. Isn't that the bummer with algebra? You make one mistake and then everything else after that, you got to go all the way back up and fix it. So what would MP be? How would I know? Would it make sense if I put negative 6 in my answer? Because that's one possibility for x, right? Would that make sense for MP? If I did that, I would get negative 6 plus 5, which would be negative 1. It doesn't make sense because, exactly, we talked about MP as a distance or the side length, okay? It wouldn't make sense for it to be a negative value. So that is one way that you can narrow down if you have 2 different x values, one of them might end up getting thrown out. So we're going to go ahead and use the 4, and we're going to plug that in here for x, and if we do that, we're going to end up with 9. So that would be MP9. Okay? Exactly, and we could find the other sides as well. Very good. Good. So thank you, Tristan, for writing out your work and working on that. But you should end up with the same thing. So although we set our proportions up differently, and this should, you'll find that this is true. So if you, were working with somebody on this problem and they had set the proportion up one way and you had done it a different way, after you cross multiply, from there on out, it should actually end up looking the same. Okay? Oh, okay. Yeah. So Will, which test was that on? Was that on the mid-unit? Or just on the quiz for 3.07? We can just give everybody a heads up on that. On the 3.07 quiz. Okay. Okay, good. Yeah, so I'm glad we reviewed it. Because if you guys want to practice maybe a few of these before the quiz, if you're like, well, yeah, I got this part makes sense, I get the geometry part, but I had no idea what you're talking about from here on down, Mrs. Williams, then where this came from is your problem set. Okay, so go to your problem set, practice some problems, and then let me know if you need help. Okay, send me a K-mail, give me a call. All right. Now we have 5 minutes left for 3.08. The good news is that we've done a lot of hard work for 3.07, and the two transversal proportionality corollary, try to say that 5 times fast, is actually very similar. Okay? So what you'll find when you go through 3.08, which I think is Monday, right? Is it today? I think this is actually Monday, so you still have some time to go through this slide. It's just 3.07 for today. It's actually going to flow from what we just talked about in 3.07. Okay? Exactly, Will. And that's the good part. You really don't have to worry about the two transversal proportionality corollary, remembering that. You just got to know how to apply it. Okay, so first let's talk about what a corollary is. We haven't come across that word too many times yet. It's a proposition that follows directly from a postulate or a theorem. Okay, so it's just basically an extension of an idea. Again, you will have a proof of this. So if you go to slide 7 of 3.08, they'll walk you through why this is true. But I think you guys will this will kind of be intuitive to you, because after you've done 3.07, here are the different possibilities. So does this kind of look, give me a sign on the face if you think this looks like the pictures that we just did in 3.07. Do you see some triangles going on in here? And see how we have some proportions we're going to be setting up? Exactly, Will. That's a perfect way to put it. Yeah, we actually see more triangles here than we did on 3.07. So this is going to apply to even, a larger situation. But here are some different possibilities. They're color-coded for you. The first one is really almost identical to the triangle, the side-splitting theorem. You're taking the smaller part of the part between the bottom two parallel lines. Now in this case we're having 3 parallel lines. It does look complex, Tristan, I agree, but don't stress because it's really not that bad. Again, same idea that we've been talking about the past couple class connects. You're really just wanting to make sure when you set up your proportion that you're matching things up. Okay? Yes, that's true, Ben. There are lots of shapes. So notice here how AB and FE match. So going horizontally across that proportion, we're making sure that we're pulling the same pieces. Okay? BC and ED match. They are both between the top 2 parallel lines. Okay? And then top to bottom, we're also matching because the AB and the BC are both coming from this transversal. Okay? FE and ED are both coming from this transversal. Okay? It would also apply to you can even do a longer length here. Okay, I'm going to jump really quickly. Let's go to one where we apply this. I want to go to this one here. Okay, now you have polling features, so feel free to put the answer in once you get it. But I want to at least get to where we set this up. So let's read the directions. It says find CB given CA equals 42 centimeters. So again, we're going to look. We can apply this proportionality corollary because we see the 3 parallel lines here. And so these transversals are going to be divided proportionally. Okay? So we have 2 things on our picture that we know. We know 18, we know 20. We want to find CB, and I don't know what it is right now, so like we usually do, I'm going to call it X. And it also tells me that CA is 42. So the blue line there is 42. I kind of run into a problem because I need to know something here. How do you think I could represent BA? I don't want to call it Y, because that's usually bad, right? We don't like to have 2 different letters in the same equation. So think about it this way. I know from A to C is 42. So for example, let me put in a number right here. Let's say that they told you this was 10. Let's say they told you that CB was 10. How would you find BA? So if I had told you that CB was 10, and that from C to A was 42. Good, 32. How did you get that, Tristan? So you'd say, well, then I would know that from B to A is 32. So if I knew from C to B was 10, good, Stephanie. Good, Tristan. 42 minus 10. So we don't know that CB is 10. Oops, didn't mean to move that. We know that it's X. So apply the same thing. Instead of 42 minus 10, we would have 42 minus X. See that? Ah, good. Now we can set up our proportion. Okay, so we could say 18 over 20. What would I need on the other side if I did 18 over 20 on this side? Match it up over here. What would I have? And again, don't read too much into it. It's intuitive. There you go, Ben. X over 42. Or X over 42 minus X. Okay? And then from there, same old, right? We're going to cross multiply, use our algebra to find X. Okay? All right. Well, we're out of time for today, but I appreciate you hanging around for an extra minute there. By the way, if you did get this all done already, you should have gotten an A. Okay? So let me know if you guys have trouble. Again, I don't think you're going to get to this till Monday, but I think probably the most challenging part of these 2 is going to be your algebra skills, okay? Not your geometry, but I can certainly help you with that as well. So come to tutor time, come back to Class Connect on Monday, give me a call, send me a K-mail. And if you don't have any questions, go for it. But I hope you all have an awesome weekend. Talk to you.